Section 27b is about classifying and ordering numbers. We're going to do a brief review of the different classes of numbers that we've seen in the past. We'll start with the natural numbers. Natural numbers, the set of numbers that look like this, sometimes also called the counting numbers. Whole numbers are the same as the natural numbers, except they include the number 0. If you remember, I said the word whole has an O, and that's how I remember that whole numbers include 0. The integers are the whole numbers, but both positive and negative. So the pattern is going to continue here forever. So that's a review of the three kinds of numbers we've looked at. We've also looked at what a rational number is in the past. Rational numbers are numbers that can be written as a fraction, the form a over b. Today we're going to introduce a different kind of number, a number called irrational, which cannot be written in the form a over b. I want to take some time and look a little bit deeper into rational and irrational numbers. See, rational numbers can, in addition to being in the form a over b, they can also be decimals that repeat or terminate, which means cut off. Now, what are some examples of decimals that repeat or terminate? 0.3 repeating is a rational number. 0.25 is a number that terminates or cuts off. 7 is a rational number because it cuts off. 0.25 repeating, or 0.4. These are all examples of rational numbers. They cut off in their decimals or they repeat. Now, an irrational number, just like it cannot be written as a fraction, it's a decimal that does not repeat or terminate or cut off. Is another word for terminate. Now, what are some numbers like that? Pi is an irrational number, 3.14159, and then it goes on. It doesn't even have a pattern. It doesn't cut off, but it's a decimal number. Things like the square root of 2. If you type that into a calculator, you're going to get something like 1.4142135, and it goes on forever. It does not terminate, it does not cut off, and it does not repeat either. A lot of square roots are like this: square root of 2, square root of 3, square root of 5. A lot of square roots that are not perfect squares underneath them are irrational numbers, and that's why we're introducing them now. And then the final classification of numbers are real numbers, sometimes written in a shorthand like this, a capital R with 2 lines. And real numbers are the rational and the irrational numbers put together. It's basically any number in the world that you can think of is a real number. Here we're asked to name the set or sets of numbers to which each one of these belong. Now, when we name the sets, we're talking about natural numbers, whole numbers, integers, rational, and irrational. We're not talking about real numbers because that's everything. So let's look at the first one. Which one of those sets will this number belong to? Well, it can be written as a fraction, but it's going to be a decimal, and it's not going to be a whole number or a natural number or an integer. So it's got to be rational, and that's it. If it's rational, it can't be irrational, and it doesn't include in any of the other ones. This one, square root of 121. Well, what is the square root of 121? It's 11. 11 is a natural number. It's a whole number. It's an integer. And it can be written as a fraction, so it's rational. So this is what we mean when we say name the sets of numbers. These are the sets of numbers that you have to write down. Well, square root of 56. If you have a calculator, you can plug that into your calculator, and you will see that it doesn't repeat, it doesn't terminate, it's not any of these, so it's irrational. And negative 36 over 4. 4 goes into 36 9 times, so this is really a negative 9. Now, negative numbers are not natural, they're not whole, but they are integers, and it could be written as a fraction, so it's rational. Here's a couple more of these. Feel free to pause the video and try them for yourselves. Square root of 64 is 8, negative 8. Negative 8 is an integer and it's rational. 8 over 3 is 2.6 repeating if you put it into your calculator. It's not whole, it's not natural, it's not even an integer, but it is rational because it repeats. Square root of 28, put that into calculator and you'll get a number that does not repeat, does not terminate, so it's irrational. And 56 over 7 is 8, which is natural. It's whole. It's an integer. And it's rational because it's a fraction. Now we have to have a brief discussion about graphing. Here we want to graph all the numbers that are greater than negative 2. Well, the last time we talked about graphing on a number line, we only included the digits that were whole numbers or integers. We only included dots on the number line. But now that we've introduced this idea of fractions, we're going to graph in a slightly different way. If I want the numbers that are bigger than negative 2, certainly negative 3 or negative 1 is bigger than negative 2. But what about negative 1.5? What about all these decimals that are in here? So what we do is we're going to put an open circle on negative 2 to show that negative 2 is not included. I can't say negative 2 is greater than negative 2 because it's not. So I put an open circle there, and then I'm going to shade. I'm going to draw a line to the right, and I'm going to put some shading underneath that line. What this signifies is that every single number, including all the decimals, all the fractions, all those rational numbers that are underneath this shading, are all bigger than negative 2. So now because we know about rational numbers, we can change our graphing a little bit, and we can use this shading idea. Here, a is less than 4.5. Actually, this is less than or equal to. So I have to find 4.5, which is about right there. Instead of doing an open circle, which means 4.5 would not work, I can put the circle filled in because we're less than or equal to 4.5, and then this is the direction where all the numbers are smaller than 4.5, including all the fractions and all the decimals. So we have to rethink our graphing now on a number line because of this idea of using rational numbers. Here we're going to compare two numbers, and we're going to replace the gray circle with one of these three symbols to make the sentence true. So the question is 2/9 compared to 0.2 repeating. Are they less than, greater than, or equal to each other? The only way to do this is to convert them into the same kind of number, and the easiest way is to take them and put them as a decimal. Well, if you plug 2/9 into a calculator, you're going to get 0.2 repeating. So the question we're asking ourselves is, how does 0.2 repeating compare to 0.2 repeating? Well, the answer is they're equal. So in this case, we'd put an equal sign in there. How about 1/6? If you put 1/6 into a calculator, you're going to get 0.16 with the 6 repeating. And then if you plug the square root of 6 into a calculator, you're going to get 2.44, and then it goes on, but I'm going to round it here. Actually, it rounds to 2.45. So which one of these is bigger, 0.16 or 2.45? Obviously the 2.45 is, so we replace with a less than symbol. The point is, if you're going to compare two numbers, you have to write them in the same way, and usually the best way to write them is decimals. Here's another example of this. I have four numbers and I want to put them from the smallest, least, to the greatest, the biggest. So I'm going to convert them all to decimals. So I have a calculator here, and you can do this yourself. 1 divided by 8 is 0.125. Square root of 1 divided by 8 is 0.3535. And then 0.15 repeating. And then finally negative 15. Now I want these from the least to the greatest, which means I want the smallest one first and then going on up. Well, the smallest one here obviously is the negative one because negatives have to be smaller. Followed by 0.12 is smaller than 0.15 repeating is smaller than 0.3535. Now the final thing that you have to do is you have to write these in the order the way they're written. So I can't say negative, well, I can say negative 15 is first, but 0.125 is 1 over 8. This one is 0.15 repeating, followed by the square root of 1/8. We're going to write these numbers from the least to the greatest by converting all of them into decimals. Square root of 30 is 5.48. 5 4/9 is 5.4 repeating. Then we have a 13, and then we have a 1 over the square root of 30, which is 0.1826. And now I want to write those from smallest to biggest. Well, the smallest one is this one, which is 1 over the square root of 30. The next largest would be 0.54 repeating, which is 5 4/9, followed by the square root of 30, which is 5.48, and then we'll finish with the number 13. So those are written from the smallest to the biggest.